video, we were introduced to this example about the average age of Major League Soccer teams. That's what X represented. We said it was unimodal and symmetric, so we wrote down N, meaning that shape, for the normal distribution. The average age was 27.9, standard deviation 1 year. Now, we ran into a problem where we were interested in finding the probability that the average was less than 27. So we drew this picture with our distribution. There's our bell curve centered at 27.9. We were interested in 27 years and finding the probability of being below that or younger than that. We ran into the problem that 27 was not a nice even 1, 2, or 3 standard deviations from the mean, and we could not use the empirical rule to get a fairly exact answer. Now we can put some ideas together to find this area of interest. In the last video, we saw how to find areas under the standard normal curve. So we just have to combine steps here. We need to take our original question, and we need to convert that to our z-score scale, or that standard normal distribution. So instead of answering it on the original distribution, I'm going to convert that 27 value to a z-score and answer it on the standard normal case using the calculator to estimate area under this curve. So let's write all this using our probability notation. So the first bit, x, is less than 27. That was my original question. So the only thing I need to do to jump over here is convert to z-scores. So in my probability statement, I'm going to change x to z now to denote I'm converting to z-scores. And remember our formula for z-scores. Maybe we'll write it up here as a reminder. Z is our observation minus mean, divided by our standard deviation. So let's check it out. Our observation we're converting is 27. The mean, or center of this distribution, is 27.9. And the standard deviation, sigma, happens to be 1 in this case. So this gives us the probability of a z-score being less than negative 0.9. So in terms of a picture, instead of answering it on this scale, I've converted it and I'm answering it on this scale. Now, we spoke about how to find this area under the standard normal curve using our calculator. So that's going to be normal CDF. Remember, if you know a z-score, that's normal CDF. If you know percentage, that's inverse norm. So normal CDF. In terms of my shading here, the smallest is negative infinity, up to negative 0.9. And again, maybe pause, try that on your calculator, and you should get something like 0.1841. Okay? When you're doing this on your own, please make sure to show all this work. Write your question in this probability notation. Show how you've converted it to z-score scale. Show that calculation for a z-score, and then write it in the simplified form. Show me what you put in the calculator and your final answer. And you would probably want to draw pictures for a little while until you start getting used to some of these ideas, but I think the pictures will help quite a lot. Let's try another one. Find the probability a randomly selected team will have an average age between 25 and 26. So I'm going to draw a picture again to help us out. So here's our 27.9 in the middle. 25 and 26 are somewhere down here. And this is my original question. What's this probability, this area? To be able to use our calculator, we want to see this z-score step of converting it. So here's centered at 0. And I need to convert those two values to z-scores before I use my calculator. So let's write it in our probability notation. Now remember, the original scale was x. So 20, I want to know the probability that a randomly selected age, X, is between 25 and 26. Our one step to go from here to this picture is to compute the z-score. So now that I have two values, I have to compute two z-scores. So the first one, 25, the mean is at 27.9 over 1 for my standard deviation. Now instead of x in the middle, my variable is z. I'm finding the probability on that standard normal case. And then my second value or observation is 26. Let's convert that to a z-score. So 26 minus 27.9 over 1. And when you work those out or simplify, you're going to get negative 2.9 for the first z-score and negative 1.9 for the second z-score. So we can use normal CDF. And remember, we're not plugging anything in from U and sigma. Leave those alone. We're going to write this as negative 2.9 to negative 1.9. That's this area right here. Smallest is negative 2.9, largest is negative 1.9. And you're going to get 0.0269. Now again, I do realize on your calculator you could define the mean as 27.9 and skip all this z-score step. I just want to reiterate, you will not get credit for doing that. And we're not trying to be cruel here. This idea of understanding this z-score conversion and the standard normal distribution is crucial in what's coming later. So we're doing this because it's very, very important for what's coming later. So please don't skip those steps. All right. A couple more here. The next one says 97.5% of teen ages are less than what value? So notice now that I have a percent. Above, I was curious about finding the probability. This time I know the probability. So this is the opposite kind of question. So if you know a probability, you're going to use inverse norm. So in terms of my picture, regarding the question, here's 27.9 in the middle. I want to know, what is this x value, what is this age that has 97.5% below it? So I can use inverse norm of 0.975. And if you do that, you're going to get a value of 1.96. Again, take a moment, try it out. Now, if you're looking at the picture, you'll notice a value of 1.96 doesn't belong here. It's not above 27.9. So something's off here. Remind ourselves, when we use inverse norm, keep mu as 0, sigma as 1. That gives you a z-score. So 1.96 is on the z-score scale, so we have one more step to do. So there's our first step. Our second step, we need to convert that z-score back to our original unit. So let's just use the formula. So again, reminder, z is observation minus mean over standard deviation. So in this case, I know different things. I know z that I'm interested in is 1.96. Observation, that's my big question mark, so I'm just going to leave that as an x. I know the mean of 27.9 and the standard deviation of 1. Now since everybody has different backgrounds and comfort levels with algebra, I'm just going to go step by step on this example. So I need to solve for x, so I might multiply both sides by the denominator so we can cancel that out. So the right hand side becomes x minus 27.9 and the left hand side is 1 times 1.96. Now we're almost done. We just need to add 27.9 to both sides. And when we do that, you are going to get 29.86 years of age, which definitely makes a lot more sense in our picture. 27.9 is in the middle, 29.86 is above. So again, no shortcuts please. Go through all this work, find the z-score, use that z-score formula to convert back to the original scale. If you want, go ahead and pause and try the next problem. You'll notice something is a little bit different about this one. You need to be careful on it. So this one is asking 30% of teams' ages are greater than what value? Hint, greater than what value? So my picture is going to look a little different. I have 27.9. I want to know, what is this x that has 30% above that value? So first, when we find our z-score, we're going to do inverse norm. We're going to be really careful. We're not putting 30% on the inside because this function is asking for the left-hand area, or the area below, so 70% or 0.7. And that's going to give you a z-score of 0.5244, which makes sense as well. All right, then step 2. I hope we don't have 70% of soccer players that are younger than half a year old. I have an 11-month-old right now, and I know there's no way he could run around and play soccer. So this answer makes no sense. We need to remember our second step of going back and converting that to the original units. So our z-score we know, 0.5244, is equal to, we're trying to solve for x, or observation, minus the mean of 27.9 over the standard deviation of 1. You do your algebra and you'll get 1 times 0.5244, multiplying both sides by the denominator, and add the mean to both sides, and you're going to get 28.4244 years old for your final answer. Right, there's one more example working through this. I would recommend trying that on your own and watching the last video in this section to make sure you really understand the material.